Hello, in this video we're going to be looking at max stack, which is LeetCode problem number 716. So this is marked as an easy problem. It states, design a max stack data structure that supports the stack operations and supports finding the stack's maximum element. So implement the max stack class. So max stack is going to initialize the stack object. The push is going to pass in an integer and pushes that onto the stack. Pop removes the element on top of the stack and returns it. And top just gets the top element without removing it. So that's just a peek, basically. So peek max is just going to retrieve the maximum element without removing it. And then pop max will take the maximum element off the top. So if you remember, a stack is LIFO, so last in, first out. So if we push the number 1, then we push the number 2, the first thing that's going to come out is the number 2. So let's look at example 1. It's just given, the input is a bunch of commands, and this is the output. So basically, let's just look at the explanation. So the first thing it does is instantiates a stack, and then we're going to push the number 5. So 5 is the top of the stack, and the maximum number is 5. Now we're going to push 1, so the stack now looks like 5, 1. But the top of the stack is 1, remember, because it's LIFO, so last in will now be first out. But the maximum is still 5. Now if we push another 5, the top of the stack is now this 5, this 5 underlined here, and it's also the maximum. So when we have a number that's equal to the current maximum, we're just going to, it doesn't really matter, but we'll assign the most current number to the maximum that's the same as the current maximum, if that makes any sense. Top will return the 5, but the stack doesn't change. Now pop max is going to return, because we had to determine which one of these we're going to use, so it's going to take this 5 off the top. So we look at stack top, it's going to return 1, and then the peak max is going to return 5, because 5 is the current max. Pop will return 1, so it's going to take the 1 off, and now we're just left with the 5. So top is 5, which is the only number. Alright, so how are we going to do this? We're going to do the toStack method. So the first thing we need to do is have a max number. We're going to store that there, and we're going to do this outside of all these methods so that all these methods can use these variables. Now we're going to make a stack integer, and that is going to be called stack1. Now we'll do the same thing, stack integer, and call it stack2. Alright, so in the constructor we need to initialize these 3 variables. So max we're just going to make equal to the integer min value. Anyway, type stuff right, it gives me the IntelliSense. And then stack1 we're just going to instantiate into a new stack. And same with stack2. New stack. And what's my little stuff here? Oops. Alright, that is all that method is going to do. So the push method is going to, so now we need to determine, well, first thing obviously it's going to do stack1 push x. So that's, at the very least, we need to do that. However, we need to determine if x is the maximum, because we need to assign that to the maximum. So if x is greater than or equal to the max number, so then we've got to do something. We've got to push the current number, stack1 push max. So we're going to push the current value of max onto the stack, and then we're going to make max equal to x. So you'll notice here that the first time through, max is going to be the min value. So the first time we push anything to the stack, it's going to push that min value to the stack. And that's going to be our little buffer that allows us to cheat a little bit on the code here. So we'll always have that extra number in there. So this will push, the first time through, this will push whatever number. In the case of example 1, we pushed a 5, so the max will be 5, and we'll push the minimum integer value as well as the 5 onto the stack. So we actually push 2 numbers onto the stack each time we do a push to maintain that maximum value. All right, now if we want to pop something off, we're going to do int result equals stack1 pop. Now, because we got that deal with that maximum value, so if the result equals the maximum value, before we popped it off, so now we don't have it anymore. So now the max is going to be stack1 pop. So basically this is saying if the result is equal to max, well, we need that value. So we're going to have to pop that off. And then that's the number that we're going to return. Return result. Hopefully that makes sense. We'll go through the debugger and it should explain things better. The stack top is just very simple. We're going to return stack1.peak. So that just looks at the top number. That's all that needs to do. All right. Now peak max is gonna, this is actually, we're just gonna return the max number. Doesn't even need to look at the stack because we got that int variable. Now this pop max is a hot mess. So the first thing we're going to do is we need to retain that max value. So int result equals maximum. So we've got that result saved. Now here's where the other stack comes in. So we need to define a temp value, and we're going to basically initiate a pop. So that's just going to pop whatever, it doesn't matter what the number is, we're just going to pop it off the top. So while temp is not equal, so that is exclamation point equal, not equal to result, then, okay, so we have this number in temp and it's not the maximum number. So we've got to retain that somehow. So we're going to push that onto stack 2. So stack 2 is kind of our dummy stack just to hold all these numbers that we popping off, and they're not the right numbers, so they're just throwing them out. And then we're going to do a temp pop again to keep, because we got to keep going with this. Because now that we're inside the loop here, the while loop, we can't use this anymore, obviously. So we just got to do it inside the loop here. All right, now when we find the number, if we have the number that is the maximum, well, we're going to return that, but we've got to deal with all the numbers we pulled off in case we didn't get to the maximum right away. So we do a while stack 2 is not empty, is empty. So all we need to do is do a push and stack 2 pop. We're going to pop each number off, and then we're going to call the push method, which will, where's my push method, which will basically, once you pop the maximum off, we need a new maximum. So it's going to go up here and determine if it's a maximum. And if it is, we're going to push the maximum and assign the max to X, and then push the number that we pass in if it's not the maximum, either way. And so that will basically rebuild stack 1 without that max number that we pulled out, because we never put the maximum in stack 2. All right, let's debug this and see if we can't make some sense of this. Okay, for my example, I used they use 515. I use 615 because 515 will not actually use stack 2 because you get the result, you get the maximum right away. So I change it to 615, which will have different answers than the example 1. But anyway, let's go through and see what we got. So we have min value, which is -2 billion, blah, 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 a new stack. All right, so the first thing we're going to do is push the number 6. So if x is greater than max, which it is, so we're going to push that number onto the stack, the -2 billion number, and make that equal to the max. And push that on to the stack. So if you look now, we've got the -2 billion and 6. So now we're going to push 1 onto the top of the stack. So push 1, max x is 1, which is not greater than 6, and so we're just going to push the 1. So the stack size is now 3. All right, now we're going to push 5. Same thing, it's not greater than 6, so we're just going to push 5. So now we've got a stack size of 4. 615 with the -2 billion. All right, now we want to do a, whoops, what was that? Oh, stack top. Okay, so now we're going to do a top, which is just going to do a stack 1 peak. So it should return the 5. And if you look, the result is 5. Okay, so now we need to do a pop max. So if you look at our stack, it is -2,615,615. So we need to get that 6. So what it's going to do, so we're going to assign the result equal to maximum, and we're going to do a pop. So stack 1 pop. Now we popped off the 5, and that is not the maximum. So return 5. And because temp is not max, now we need to push that to stack 2. And we need to do a pop again. And now we've got the 1. Well, the 1 is not the max, so we're just going to push that onto stack 2, and yeah, right here, and then do the pop again. So now we have the 6. So now we're just going to pop that off and return it. Okay, so now we have the maximum. All right, so now stack 2 is not empty because it's got the 5 and the 1 in it. So now we just need to do a push of stack 2 pop. So we're going to push the 1, and 1 is greater than the max, which is back to the -2 billion. And so we'll make maximum 1 and then push the 1, and now I've got to push the 5, right? Yeah. And that is greater than 1, so that becomes the max. So we'll push that. So if you look at stack 1, now we're back to, well, now we've got 2 number 1s and the negative, but it does return the 6, which is what we want. And the answer is, come on, result, 6. There you go. Okay, now stack top. Now this should return the 5 because our stack should technically look like this, 1 and 5. And so a peak, and it does in fact return the 5. So now we need to peak max. And peak max is just going to return the max, which is 5. That was easy enough. Now we do a pop. So that's just going to pop, and the result is equal max, and so we're going to pop again, which will, yeah, that just leaves the 1. And return the 5, 5, and then stack top, which will just return the 1. And that is the answer. So now I'll run it through LeetCode and see where I messed up. So close. I forgot an ending parenthesis here and the semicolon. Otherwise, I got all the way down to 51. Almost. Okay, so that was accepted. We'll submit it. Faster than 58%. Memory usage 59. So the time complexity is O of n. All we're doing is pushing and popping, and so there's nothing The more numbers we have, then the more space the more time it takes. And space complexity is of 1. There's nothing that increases or decreases. We don't add any numbers other than the input parameters. And that is it. Let me know if you have questions, and thanks for watching. We'll see you next time.